Hey, Vlad here, devinsidey.com. Welcome to another video. In the previous video, we have been introduced to Monads, and I will be the first to admit that it probably created more confusion than clarity. So today we're going to start from scratch and write a super simple program and spend the next few videos massaging it until monads appear. Let's do this. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, which is the editor of my choosing, and it is fully maximized. We're using a plugin called Terminus, which allows us to emulate a terminal inside of Sublime Text, which we use to run SBT, and usually we use it to rerun the test every time we save the file. I already have a simple project set up for you. It's not as simple as usual because this is not just a Hello World project, because it actually is a multi-build. So we're using 3 projects over here, but I'm going to walk you through everything so that you don't feel lost. So every folder is already opened or unfolded, and the important files are the build property file, which is over here in project. We're using the SBT version 128. Then the next one is the plugins. The only plugin that we use is Scalar. It's the plugin that we have been using all along. These are the Scalar settings over here. Right, so these are the same settings as we have been using. Let me show you actually everything like that, so that if you're interested in the settings, you can pause the video and see all of them at a glance. But these are the same settings as we have been using in all the other videos. One difference is that we're using this syntax over here. We're saying this build /, which means that we're going to use these settings for every sub project. All right, now we're going to go to the build, and the build is going to describe all of these 3 projects. So we're using Scala 2.12.8. We have this special flag, which is a triggered message. So this will make sure that if we're using continuous compilation or continuous running of the tests, that every time we rerun them, the output is cleared first, so that we see only the last iteration. SBT1 came with a feature called server, which we haven't been using at all so far, and until I'm going to make a video about this, we're not going to start using it. So we're disabling it over here. We're using quite a few compiler flags, the feature deprecation, implicits, and higher kinds. As I mentioned in the previous video, there will be a lot of parametric polymorphism involved, and quite a bit of implicits as well. Over here you see a very fancy prompt which says welcome to the Monads project, because the entire folder is called Monads. This setting is over here. Just like this, and this is just a function called fancy prompt. The string comes in, another string comes out. This is our first project. It's called FP library. I called the folder 1- because I wanted them to have an order, right? So each project has this shell prompt. So we have the FP library, then we have the application library. Usually we have just some library and our application, but in functional programming we separate the part. In fact, in most applications, this is what you should do. You should have your main in one project and the rest of the application in the other one. So we're going to have the functional programming library, which we're going to write during these videos. We're going to write an application. I call it application library because it will become clear why it's called application library and not just application. And then we have the so-called end of the world, and the end of the world will just contain the main method. Okay, and as you can see, our dependencies are very, very simple. The end of the world depends on the application library, and the application library depends on the functional programming library, right? So everything is very, very linear. There are no diamonds, nothing weird. If I keep scrolling down, then we will only see the aliases. So if I type LL, it will be the same thing as typing projects, right? Like this, and we see all of our projects. Instead of saying project FP-library, I can just say CD FP-library, and I can just say root, which will jump back to the original project, and I have aliases to jump into each individual project. We have the functional library, we have the application library, and we have the end of the world, which contains the main method. So inside of the application library, we have our program, and I split it the panes in such a way that you see those layers, right? So this is the top layer, which will contain the functional programming library, which right now doesn't contain any files, so it will stay empty for a while. Then we have the program, which comes from the application library, which just has a method called run. This is not the main, but it's basically the main, right? It's a regular method called run. It gets the arguments, it prints out the hello world. And over here at the end of the world, we have the main, which is over here, right? So it's in the next layer, which just calls run on the program, right? Nothing fancy so far. And over here we have SBT, and most of the time we're just gonna keep compiling the main application. All right, so this is all that we have. I'm going to collapse the sidebar now, and I'm going to create more space by moving this down. I want this line to stay visible, so I'm going to do this, go here, press down a few times. Okay, so this is the only line that you need to have visible from this layer. And now we're going to spend some time writing our simple program. So we're going to write a tiny program which accomplishes the following. Our country's government decided to change the currency, and because this is not happening for the first time, our people are pissed, and the government is aware of that. So it gives us programmers the task to program the ATMs in such a way that if people deposit some money, whatever they deposit will be rounded to the next 100. So if somebody deposits a 5, whatever currency it is, let's say $5, then what comes back is 100. If they deposit 123, then what comes back is 200. The error handling policies are very generous as well. All right, so let's just go and start writing this program. Okay, so the first thing that we're going to do is we're going to remove all of that. Let's start by saying display hyphens. So I'm just going to type out the entire program, and in the end we're also going to display hyphens. Okay, like this. Then we're going to display the question. Then I should type properly, question. Okay, then we're going to have some input, which is going to be a string, by calling the method called prompt. We don't have any of these methods, but we're going to have them in just a few seconds. So we're going to have an integer amount, which is convert string to int from that input, right? So you can imagine how this program is going down, right? So there will be some question, then the user will be able to put something in, which will be a string. We're going to convert that string to an integer, right? Then we're going to make sure that this is a positive amount, which is going to be an integer, by saying ensure amount is positive by giving the integer amount. Okay, then we're going to have the balance, which is basically the result, right? So we're just going to round whatever the positive amount was, and then we're going to produce a message to display, right? So we're just going to call create message. We're going to give it the balance, and then in the end we're going to display the message. This is basically the entire program, which doesn't compile now because we don't have any of these functions. So what we're going to do now is we're just going to go and create them. Okay, so the first thing that we need is the hyphens. So we're going to go here and I'm going to say private val hyphens string equals, these are my favorite hyphens, Unicode 2500, like this. Okay, times 50. Okay, so the next one is going to be the question, private val question. Let me actually go down like this. All right, question, which is also string, and it's going to say, okay, how much money would you like to deposit? Okay, like this. Right, so the next thing that we're going to have is private def display, which is just going to delegate to print line. So this is going to be an input of any, and it produces a unit. And let me scroll down a bit. Okay, so everything that it will do is print line input. And by the way, I'm going to leave a comment here that this is a side effect, right? Side effect, which is writing to the console. Okay, the next one that we have is the prompt. So we're going to have private def prompt. We're denoting with the empty parentheses that there will be some side effect involved, but what the prompt produces is actually a string. So we're just going to say Scalar.io. Let me scroll down a little bit. Okay, like this, standard in read line. Okay, so I'm going to also say this is a side effect reading from the console. Okay, now technically this is not a side effect, but this is not a referentially transparent function, right? So every time it returns something different, so we can treat it as a side effect. The next one is private def convert string to int, get some input, which is a string, converts into an integer just by saying input dot to int. Notice that we're not handling exceptions here, so there's a potential side effect. Okay, so this is not a side effect, this is a potential side effect, throwing of a number format exception, like this. Okay, the next one is going to be ensure amount is positive. So some amount comes in, right, int comes out. Okay, and all that it will do is we'll say if amount is less than 1, right, then just return 1. As I mentioned, the arrow handling policies are very generous. Otherwise, just return amount, right? So basically, anyone can come to the ATM, basically not put any money at all, and they will get 100 back, right? This is just an example. The last one is the round functions. So we're going to go here. I'm going to say private def round, which is in amount of integer, right? Integer comes out. Okay, so we're going to say if is divisible by 100, giving an amount, then just give it amount back. Otherwise, round amount plus 1. So do plus 1 until we reach our 100. Okay. So now all we need to do, and by the way, this is going to be a tail recursive function, right? So we can say at Scalar dot annotation dot tail rec. Okay, like this. So we're rounding, and the last one that is left is divisible by 100. Some input comes in. Let's call it amount, right? And a boolean comes out. Okay, we're going to say amount is divisible by 100 equals 0. And by the way, I'm using Fira code, which makes this look awesome. So if you don't know what Fira code is, I already made a video about this. Okay, there is one more that I forgot to add, which is going to be private def. It's called def create. Oh, why did I say def again? I remove one of these, create message. So the balance, which is an int, comes in, string comes out. I'm going to use string interpolation over here like this. So I'm going to say congratulations. You now have, let's say that it's dollars, USD balance dot. Okay, let's see if I forgot something. No, I didn't. Okay, everything compiles. So now we can run it for the first time. Let's just do run. Okay, so it says how much money would you like to deposit, and if you put like 1, 2, 3, then 200 should come out, and this is exactly what's happening. It says congratulations, you now have $200. And by the way, I'm going to replace the prompt with we're just giving some numbers. So I'm just going to say that a 5 comes in here, right, as a string, right? So this way I can just run the program, and I wouldn't be able to, I wouldn't need to put this number in every time. So I can just save the file, run again, save the file, it runs again, save the file, it runs again. In the previous video, I mentioned that one of the jobs of the monad is to help managing side effects. But in order to do that, we need to get rid of the side effects first, so that the monads have something to manage. So we, the functional programmers, are faced with at least 2 problems. Number one, we somehow need to interact with the outside world. At the very least, we need to be able to ask the user for input, and we need to be able to output something on the console. How are we going to do that without side effects? Number two, even if we manage to find a way to do this, our entire program still returns a unit because we're in the JVM, and this is how the main is defined. And this is one of the reasons why we also have this separation between this thing that has the main and between this thing that has our function, so we could potentially change this unit to something else. So what we, the functional programmers, do is we cheat. Instead of admitting that it is impossible to write a useful program without side effects, what we do is we separate the parts that are pure from the parts that are impure. We minimize the parts that are impure and pretend like we don't care about them, because A, there's only a few of them. More specific, there's only one of them, and B, they're in a separate project. So we say our project is going to be purely functional, very pure effects, right? And the separate project is going to have side effects, but we don't care about it. So what we do is, in our entire application, instead of performing side effects, we're just going to switch to describing side effects. And then by the end of the world, we're going to have a main, or so-called interpreter, which will interpret this description. And this is going to be the only place which will actually perform the side effects. So before removing all the side effects, we have quite a few of them, what we will do is we will wrap the entire main, the entire run, into a description, and then interpret it in the main. And before that, I will create a copy of this entire program, so that by the end of the series, we have something to compare with the original, right? So I'm just going to copy that. I'm going to create a new file. I'm going to paste all of that in. I'm going to call it original program. I'm going to save it as original program.scala, right? Which is now over there. So let me close it. Let me collapse the sidebar again. Let me create a bit more space over here. All right, so in programming, a function that doesn't take anything, or basically takes a unit and produces the result, is called a thunk. So what we're going to do is we're going to have a tiny type alias. We're going to call it a thunk that can produce some A somehow, right? So it's basically a function that takes a unit, or basically nothing, and produces an A. So a description of the program is basically a thunk. So right, so we can say type description of A is basically just a thunk of A. Okay, so what we can do now is, instead of returning a unit over here, we can return a description of a unit, right? Description of a unit, simply by doing this, right? So now this doesn't produce a unit, it produces a description of the unit. And now we need to adapt our main a little bit. And by the way, I mentioned that the main is called the interpreter now, because as you can see, it doesn't actually do anything anymore, right? So we're going to call it interpreter like this. I'm going to call it interpreter over here, right? Let me collapse the sidebar as well. So now, instead of just calling run, we're going to have a tiny helper, which is going to be called interpret. right? So it can interpret any A, okay? So we're going to give it a description, right? By giving it a program dot description, right? Which is this type alias over here, right? It's going to be a description of some A, and it will produce an A. What will it do? Well, it will just call, it will just basically evaluate that thunk, right? So it will just do that. I'm going to make it a bit more explicit. I'm going to say dot apply like this, okay? So what we're going to have now is we're going to get the description, right? We get the description program dot description, which is a unit, okay? So we're going to say program dot create description, which is going to be the name of our run, like this. So our run is now just called create description, okay? So we're passing it the arguments, even though the arguments are ignored actually, but still we're going to pass them in, right? So now we have the description and we have a way to interpret the description. So at the bottom, we're just going to say interpret description like this. And now we see an error because I don't know how to type, okay? This is the description, right? So this thing was calling that, okay? So now we have exactly the same code basically as before, the same behavior as before, okay? So the idea is that our application becomes a pure library, which is why also I called it application library, right? So we have the end of the world, which just interprets the library, right? So in our library, there will be no side effects, and it would be really awesome if Scala, or in fact any other language out there, would be able to ensure that we're actually not performing any side effects at all. But trust me, the situation in Scala is actually better than in most languages, mostly due to the fact that Scala is an expression-oriented language. So because there's no way to be sure, what we're going to have is we're going to have a few colors which will help us to figure out if we made a mistake or not. So what we're going to do is we're going to go over here and we're going to say print console dot red. So this line, it will inject. I actually don't want to print line. I want to print. This will inject the ANSI code for the red color. So everything that we will print out after this, basically, if I save the file now, the whole program will become red. Now over here, before we interpret, I want to say console dot green, okay? And by the end, I want to reset it like this as well, right? So if we did everything right, then all the time we should see green. But as soon as we make a mistake, for example, if we go to the constructor over here, I'm going to say print line high, then we're going to see red. So as soon as we see something red, which is why I'm also going to create a bit more space over here. As soon as we see something red, we know that we made a mistake, okay? Like this. Okay, let me remove it. Cool. All right, before we continue, let's make some refactorings, because it is a common critique of functional programming that it requires quite a bit of boilerplate machinery code. And even though most programmers claim that most of it can be abstracted away in libraries, I decided to show you instead. So what we're going to do is we're going to go into our functional library over here. We're going to create a new file over here. I'm going to call it package Scala. And we're going to move the type aliases in there, because type aliases, they cannot live outside of objects. So I'm going to cut them out. Okay, I'm going to go up over here and I'm going to create a package object, and we're going to just say FP library. Okay, I'm just going to put them in over here. And now we need to go over here and say that this is not program dot description. Sorry, like this. It's just description now. Okay, like this, and we just need to import the library. Import FP library, and we're going to import it in our program as well over here, right? Like this. Let me collapse the sidebar. Okay, so basically we just moved the type aliases into the package object of this library. Now over here we're importing the library, therefore we have access to the description, and in the main we're importing the library, therefore we also have access to the description, and everything works like it should. Remember, we have the layers, right? So this has a dependency, so this has a dependency on this, and this has a dependency on that, right? So everything is fine now. What we'll also do is we're going to go to the functional library again, and we're going to create another file, and I'm going to call it description. Description.scala. Did I type it right? Description. Yes. Okay. So we're going to say package FP library, and we're going to have an object description over here. And what we're going to have over here is we're going to have just a helper method. So Scala has this thing called by name parameters, right? Like this. So this will allow us to create descriptions a bit more efficiently, right? So all what this will do is it will actually create the description for us. Okay, so because this is a by name parameter, we can now over here, instead of doing that, we can just say description dot create and just pass in the rest of the program and everything stays green. Okay, so what we now have is this tiny abstraction that can describe any kinds of effects. For example, input or output, or even the fact that an exception is going to be thrown. Now, it's not going to handle the exception in any way. It's just there to describe that an exception might happen. Now, remember in the previous video, I said something along the lines of monads, blah, blah, Kleisli composition, blah, blah, of Kleisli arrows. So what we have here is actually a Kleisli arrow of array string to description of unit. As a reminder from the previous video, in category theory, a regular function from A to B is called an arrow, and a special kind of function from A to something something of B is called a Kleisli arrow, which is named after a Swiss mathematician, Heinrich Kleisli. So I'm going to go to the package, and I'm going to have two type aliases that we're actually not going to use, but I'm just going to put them in just sort of as a reminder. So I'm going to say private type, and I'm going to also disable the formatting. So I'm going to say format off. Also, in this video, I'm going to be struggling with space. Okay, so let me create more space. Okay, so we're going to have format off, a format on over here. Okay, so we're going to have a private type. I'm going to call it regular arrow, right? There's A and B, and this is just a function that takes an A and produces a B. Okay, and we're also going to have a private type Kleisli arrow, which it has A, B, and also some sort of C, which can take a whole, right? So this is a function from A to C of B. Okay, so let me inline, let me indent a few things like this. This should be an equal sign, like that. Okay, so we're not going to use these type aliases, but just to imagine things a bit better. So what we have over here, right? So our A here, this A is an array of string, and our C of B is a description of unit because our B is unit. Okay, so we have already one Kleisli arrow, but if we have only one Kleisli arrow, then there's nothing to compose, and if there's nothing to compose, then I can't show you monads, because monads are there for the composition of Kleisli arrows. So we need to find something to compose, and quite frankly, we're in luck, because we have quite a few functions over here that produce side effects, and so far we just cheated by wrapping the entire thing into a description. So how can we compose all of these small ones together to create a big one instead of creating this big one manually? And also, why do I keep saying the word compose? Where's this composition? I'm glad you asked. Now, the goal is go to display and prompt and make them return, instead of, for example, display right now, it returns a unit. All right, let me scroll down. Display returns a unit. So the goal is to make it return a description of unit, and then to go to prompt and to say that it's going to return a description of string. But before that, we're going to rewrite the entire program in the so-called point-free or Tacit programming style. And we're going to do that so that you can see this composition that I'm talking about. As mentioned in the previous video, we're going to derive monads from two different angles in this series. One is going to be in the regular programming style, which I'm going to call point. This is the programming style that is known to all programmers. And the other angle is going to be in this point-free style, which I'm going to explain in just a few seconds. Now, point is just a fancy way of saying argument. So in the sense of argument to a function. So a point-free style is a style without function arguments. So whereas in the regular style, you call a function and then you bind the result to some variable, in this case input, and then you just take this and you stick it into the next function. In the point-free style, you just compose functions together, and then in the end of the world, you have this one big function that you just call once. It will all make sense in just a few minutes, don't worry. So what we're going to do is I'm going to copy the entire program, I'm going to create a new file, and I'm going to call it point-free program, right? So we have the program and we have the point-free program. Okay, I'm going to paste it in. I'm just going to call it point-free program. And over here at the bottom, I'm going to say that we want the point-free program. And also the previous one, I'm going to call it point program. Okay, and I'm also going to rename the file. So I'm going to go here. I'm going to say point. Right, so we have the point program, we have the point-free program, and we have the original program. Okay, so there's nothing that is going to be changing in the main, so we're just going to go down like this. I still want you to at least see this one line which says, where is it? Let's do this one, description.apply. Yeah, this is the most important one. There's also the, interpret the description, but this is the most important one. Okay, we're not going to have anything in the functional library, so the most space that we're going to be working with is over here. Okay, so the first step is going to be just to build a chain of functions before we arrive at the point-free style. So, for example, if I just press enter over here, and I press enter over here, this starts to look like a chain. So I'm going to do that over here as well, right? And at the bottom as well, okay? I know that right now it doesn't really make sense, but you will understand it in just a few minutes. Okay, so the next step is going to be to remove the arguments, right? So instead of saying, okay, this is the input, where is it used? It is used over here. Why don't we just inline that? So I'm just going to cut it out. I'm going to put this over here. This way we don't need the input like this. And now I can go over here and I can keep inlining this like this. Okay, I could even do that like this. Okay, to show that there's nothing here. There's nothing here like this. Okay, so I'm just gonna keep going like this. Okay, Scalar form doesn't like the fact, so I'm just gonna do that for now. Okay, so we can just keep going like this. So the integer amount is used over there, so we can just take this thing, cut it out, put it over there. Okay, and I'm gonna cut this out. So this thing is used one time over there, so we're gonna take the whole thing. It's a simple substitution model. Okay, so balance is used only there, cut it out, put it over there. Now the message is used only over there, so let's just take this whole thing, put it over there, remove all of these variables. Let me do this and that and that, and let me save. Okay, yeah, there we go. So Scalar form made the rest for me. Isn't it interesting that side effects already stand out a little bit, right? So we have display over here, display over here, display over here. So everything either starts with display or it ends with something that doesn't take an argument like this. On our road to the point-free style, we need to realize that our only unit of computation can be a function. And as of right now, we don't have only functions. We also have regular values like hyphens or questions, for example. So what we're going to do is we're going to convert them into function then that can take absolutely any input whatsoever and produce what they need to produce, the string in this case. Also, by the way, let me copy that hyphen and put it over here like this. Okay, let me save. Okay, so this is not going to be a val hyphen. This is going to be a def hyphens, and it's going to take any input whatsoever, right? It's going to be an any, right? And it's going to produce a string. Okay, so the input is basically ignored, right? But now it can produce a string. So now we're forced to actually call hyphens with some argument. So we have to go here and we have to say that we're going to call it. Well, we're going to call it with unit. Okay, and the same thing over here as well. I'm going to call it with unit. Let's see. Yeah, now it works exactly the same as before. Let's do the same trick with the question and with the prompt. Okay, so we're going to have def question, which takes some input, which is any. Okay, prompt is technically a def, but can technically take any input whatsoever. Input any, produce a string. So now we have to go into fix them. So now we have to call prompt with absolutely any argument, and also which one was the other one? Question. Question. Where's question? Over here, right? So we have to call question like this. All right, there we go. Now we started this section with chaining methods, but we didn't chain all of them together. We chained them only partly. Why didn't we do it with them? Well, we actually can. So this is basically the same code as the result of unit, right? So and where's this result used? Well, we can put it over here, for example, right? Because question can take anything that it wants. So if you put it over there, it's the same thing. And now we can do the same trick as before. We can just inline it like this. Okay, remove that. Press enter over here. Press enter over there. Let's save. All right, so it's exactly the same code, and we can keep going like this further. So we can do this one. We can cut it out and paste it over here. Let me press enter over here. Let's save. Same code, and we can take the whole thing over here, remove a few lines, paste it over here, right? There we go. Same code. Let me press enter like this. Okay, something is wrong. Display over there. There we go. All right, so now this is a chain which doesn't actually, it doesn't even fit into this one screen. In fact, there is one more over there. So we can go like this. We can press enter over here, create, replace this curly brace with the regular parenthesis like this. Now we can go down and replace the last curly brace with a parenthesis like this. Okay, so this is our entire program, this gigantic chain, and we're lucky that nobody writes programs in such a way. And by the way, we're not using args anywhere, so now we can actually start using it, for example, like this. Okay. Because all the argument to the hyphens function is going to be ignored anyway, so we can put anything in that we want. All right, so this starts to look very, very unfamiliar, but believe it or not, this is still not the point-free style, because even though we're not giving names to our points, to our arguments, we're still passing them along. In order to arrive at the actual point-free style, we need to have a helper which will automatically compose functions for us. So we're going to go to the functional library over here, right? I'm going to create a new file. I'm going to call it point free.scala. Okay, so let me just make sure that it has been created over there. Yes, it has been. Okay, so it's going to be in package fp library. Okay, so we're going to have an object called point free, and it will just have a function called compose. This function that is called compose is going to take two functions, f, which is going to go from a to b, and it's going to take a function g, which was going to go from b to c, and it's going to produce a function that goes from a to C. And because in these A, B, C don't exist anywhere, we have to introduce them over here, A, B, and C, like this. Okay, there will be some implementation in just a few seconds. And also, we're going to work with parametric polymorphism a lot, and it's a common practice in functional programming, or in a programming style which uses so much parametric polymorphism, is to name the variables after the types. So this is a function from A to B, so we're just going to call it AB, and this is a function from B to C, so we're just going to call it BC. Okay, so this is the very common composition, and if you're unfamiliar with functions that return other functions, there's a simple trick. You just basically start the function right away. So you need to create a function that produces that takes an A and produces a C. Well, you just start writing it. You say, okay, this is going to be a function that will take some A and it will produce some sort of C, right? So we just need to produce a C. Produce a C over here. And with this, there's actually an awesome video about this. It's called Liberties, Constrain, Constrains, Liberate, I believe, by Runar, Bjarnason, and I'm gonna have a link down in the description about this. It's basically if you're programming in this style, it's very hard to write some code that is going to be wrong, because all you need to do is to do the so-called type Tetris, right? So you basically need to follow the type. So in order to implement this function, all we need is to see, okay, what do we have? We have an A, we have a B, and we have a BC. Okay, so what can we do with an A? Well, we can stick it into this function AB. So let's do that. So if we stick it to AB, what will come out? Well, B will come out, right? B will come out. Okay, so now we already used A and we already used AB. Everything that is left is BC and B. Okay, so now what we can do is we can stick this B into the BC, and what will come out is C. Okay, and what do we need? Oh, we wanted to produce a C over here, right? This thing. Okay, so we already produced a C, so now we can just return it, and this is the implementation of function composition. So what this allows us to do is, I'm going to have a small comment over here, we can say that if we wanted to have a function that goes from A to C, but we already have a function A, B, and BC, so we can just call compose with A, B, and BC. Okay, this is what will allow us, this function will allow us to do this function composition. Now, what we're going to do next is we're going to have some special syntax for this, so that we don't have to call it in such a, I'm going to call it data-oriented style. So what we're going to do is we're going to go to our package object over here, and we're going to have an implicit final class, and I'm going to call it Infix Notation for point free. Right? There's going to be A and B, and the goal is to not have the C here, but to have the C on the function. So this is going to be A, B, and there will be a private val, which is going to take the function from A to B, right? A, B, like this, okay? And it extends any val, because we're so much concerned about performance. So now we're going to have a def, and we're going to call it semicolon. Semicolon is already present in Scalar, so we need to surround it with backtick so that it works. And the whole point of this was so that the C comes in over here. Okay, so now we have the function BC that comes over here, right? It's a function from B to C, like this, and it produces the function from A to C. And how does it do it? Well, it just calls point free. It says compose AB, BC. So now this whole thing, it might have been a bit fast for you, but this whole thing, all that it does is that if you want to construct AC, all we need to do is we need to say AB and this semicolon BC. So again, instead of doing this, AC point free dot compose AB, BC, we can just use this semicolon, and we can also write it on a different line, right? So for example, we could do this like this. Right? So instead of this whole chain now, we can use this function composition, which will do it for us. And by the way, I'm also going to define a few aliases. So in Haskell, for example, this is called a dot. And what I like to use is an arrow. So I'm going to use hyphen, hyphen, and then an arrow to the right. And because Fear Code made a proper arrow out of this, I'm going to leave this for you with spaces. Okay, so this is what I typed in over there. And also, it might be possible to inline these functions. Is it possible? maybe. So this annotation just gives the compiler a hint that it can aggressively inline these functions. All right, so now we can start composing our functions. In fact, I forgot to save the file. But before we actually do that, even though Scala has a built-in eta expansion which will turn our defs into functions, in order to avoid issues with type inference and also to have more clarity, we're going to rewrite all of our defs into functions manually. So instead of this one, def hyphens, instead of this, we're going to have a private lazy val hyphens, which is going to be a function that takes an ini and produces a string, right? So it's going to say equals underscore comes in, right? We can actually call it input the same as before, right? For example, like this, and it's going to behave exactly the same way. I accidentally removed the s. There we go, hyphens. Okay, I'm not going to call it input. I'm going to call it underscore because we're not really using it. Okay, so what I'm going to do now is I'm going to go through all of them and do the same thing, right? So I'm just going to duplicate that line. I'm going to call it question. I'm going to remove that. That should be fine. Okay, so now we have a similar thing. It's called display. It takes an any, but it actually produces a unit like this. There we go. There's a curly brace like that. Sublime try to help out. Oh, this one actually cares about the name of the variable because it actually uses it. Okay, so we're gonna have input over here. Okay, so now let's go to prompt. It's gonna be like this, prompt, any comes in, string comes out. It doesn't use the input actually, like this. Okay, so just gonna put a 5 over here like this, so we don't need this line. Let's see. Yes. Okay, so let's do that. Convert string to input. Okay, so string comes in, int comes out. This time we're actually going to call it input. Arrow to the right. Let's remove the 5. Let's scroll down a bit. By the way, there is a new version of Sublime that came out, and for some reason I can't always scroll down. Like I use my scroll wheel, but it doesn't scroll down always, so I have to do it 3 times sometimes. All right, let's go here. This one is called like that. Ensure blah blah. Int comes in, int comes out, and it's actually called amount like this. All right, there we go. All right, let's do it with this one. It actually has the same signature, round like this. Okay, this tail rec thing is probably not going to work. Let's see. Yeah, it's not going to work. Let's just remove it. It's fine though. It's just an educational example. Okay. Okay, duplicate, go down and grab this one, go up, grab this one. It's int to boolean like this. All right, save it. Okay, and the last one is called create message, which takes an int and produces a string, not string, and it takes in a balance like that. There we go. Everything is now vals. In fact, not everything is vals. Our main function is still a def. So let's do, okay, lazy val create description. It's a function from array of string to description of unit equals, come on, equals, args come in, arrow to the right, and the rest should still stay the same. All right, now there are only 2 things left to do because we still have the create, which is still a def. So we need to go to description to create, and there's actually a problem with it, right? So if I try to do something like val create, actually it has to remain a def because it has this generic parameter. I'm going to call it broken create, and you will see now, you will see in a second why. I'm going to call it broken create. Okay, so this is technically a function that takes an a and produces a description of a, but it doesn't take an a, it takes this by name a, right? So I would need to use an arrow over here, and Scala doesn't allow me to do that. Right, so I'm gonna comment this out, and this is why you will remember that this is why it's broken to a function, right? Because a is already evaluated at this point, so there's no point in converting it into a by name function, basically. All right, let me save that. And the last, so if I start using broken create over here, broken create, right, everything will turn red. Okay, the very last thing that we need to do is we need a helper that will convert a function that takes an array and just ignores it. Okay, so we're going to have a function over here. It's going to be called ignore args. It's going to take an array of string, and produce a unit. And how is it going to do that? The array will come in over here, and what it will produce is unit like this. Okay, ignore args. So now we can actually finally rewrite our program into the point free style. So let me create some more space over here, as much as I can. In fact, I'm gonna do this for now because I need a lot of space. Okay, so I'm gonna go here and I'm gonna copy that. I'm gonna comment it all out. I'm gonna go down and paste it over here. In fact, I'm not gonna paste it. I'm just gonna use this. Right, so this is what I need. I need the signature. Okay, so now we basically go over here, right, to the last sort of, it looks like the last point, but this is actually the first thing that is happening, right? So this is happening, and then this is happening, and then this is happening, even though, you know, we would like to read it top to bottom. In fact, we're forced to read it like from the bottom up. So the first thing that is happening is that the arguments are being ignored. So we can say over here, we can say ignore args, and I'm going to use the semicolon over here, right? And the next thing is what is happening is hyphens, right? So we can just type in hyphens. Okay, I'm going to use this semicolon over here again. Okay, the next thing that is happening is display. And the next thing that is happening is question display prompt. Okay, so question display prompt. And the next one are convert string to int, ensure, and round. Okay, convert string to int, ensure, and round. The next ones are create message, display hyphens. Right, let's create message, display hyphens, and display, and then broken create. Okay, display, and now broken create. Okay, let's see. Obviously, I made a mistake somewhere. I saw some arrows, or maybe I saw something red. Maybe it's not an arrow. Maybe it's actually. Oh yeah, it's display dot. It's what is a description dot broken create. Okay, typo 36. It's display like this. All right, so now it behaves exactly the same way, and it is green. In fact, why is it green? Am I running the wrong program? I'm probably running the wrong program. Hold on, it shouldn't be green. No, it is the point free. Oh, I kept changing the point program instead of the point free program. At some point, I switched. I'm sorry, that was not my intention. All right, so what we're gonna do is we're gonna say this is the number 2, and this is going to be the point free program like this, and now this is going to be a point program like this. And so point free program is going to be a 2 here. The point program is actually the point free program, and this one is actually the point program. Okay, like this. Okay, so in fact, what I can show you now, because I was really surprised that that this thing was actually green. So I'm gonna comment this out, this one, because it was not supposed to be green. It was supposed to be red. Hold up, let me do this like that. Let me do this over here, right? So this should also be red, right? Because we're using the broken create. Okay, I was really surprised before. Sometimes happens. Okay, all right. So let me comment this back out again, like this. Let me comment this in again. Come on, like that. Let me create more space again, like this, like that. Okay, let me save it. Okay, now let me also have format off over here, and I want to have a cursor over here like this, and I also want to have this over here, this over here, this over here. Let's also turn format on at the very bottom like this. This whole madness will make sense in the end, I swear. All right, like this. All right, like that, like that, like that, like that, like that, like that, In fact, these two are the same, like that. Okay, so in fact this whole thing is longer than broken create. Okay, like this. So this is what's happening, right? This is function composition, and in fact this function composition is actually built into the language. There's a method called and then, so I can just go over here and say and then, and it will behave exactly the same way as before. Let me show you this like this. Let me save. Right, so I can replace all of these like that with and then, and it will behave exactly the same way. So this kind of composition is already built into the Scala standard library. So what we're going to do now is we're going to use arrows instead, because I sort of like to think of it as data flowing through a pipeline of functions. Okay, all right, so why the hell did we do all of this, and what does this have to do with monads? Well, on one hand, nothing, but on the other hand, everything. The reason we did all of this nonsense is that so I can show you a program written solely in form of function composition. To be more specific, this is a function composition of simple functions. And now I'm going to show you how to compose Kleisli arrows. But before that, we actually need to get some of them. All right, so let's go to display over here. Let me duplicate that. I'm going to put that over here, right? And let me also duplicate that. Okay. So now let's convert it into a Kleisli arrow. So let's say that it doesn't return a unit. Let's say that it actually returns a description of unit. Description of unit. How does it do that? Well, it just goes until the arrow and says description dot create over here, right? So, and I have to call it somehow differently. I'm going to call it display Kleisli. So what's going to happen now, if you're going to go up, and instead of display over here, we're going to start using display Kleisli. Well, we got unlucky because our code actually compiled, but the behavior changed. And yes, I did not misspoke. I said unlucky instead of lucky. When the code compiles, but the behavior changes, this is not luck. Let's see what happens if we replace all of them. So if I go to display, I'm just going to do that. I'm going to do that, and I'm going to do that. Okay. So now we actually got more lucky because now the compiler is actually complaining. So what is it complaining about? So what happens here is that display Kleisli is a function that takes an A and produces a description of unit. Now, if we call this, then what this expects is a function that would take a description of unit and produce something else, right? Some sort of C. But instead, we're giving it this function. And this function has a type of any type A, let's say even that it was a unit, and it produces a description of unit. So remember, like this, our function composition, this arrow, it wants an A to B and then B to C. So this B has to be the same as this, right? But it's not. So we need to find a way to compose a function that doesn't take an A and produce a unit. It takes an A and produces a description of unit with a function that takes a B and produces a description of unit, right? So it doesn't go from B to C. It goes from B to description of C, right? So for this, first of all, let me revert all of that nonsense like that and like that. And let me start using display again, at least for now until we finish. Okay, so what we're going to do now is we're going to go to point 3 and we're going to have a new kind of composition. So we're going to go here and in fact, I'm going to copy this one like this. Okay, so we're going to call it compose Kleisli. Compose Kleisli. And what Kleisli will do is instead of producing a B over here, it will produce a description of B. And instead of producing C over here, it will produce a description of C. Whoops. Description. Come on, description of C. And what will come out is also a function that takes an A and produces a description of C. Right? So these are Kleisli arrows, and therefore this is Kleisli composition. And let me rename them actually. So now this is ADB, this is a BDC, and what happens here is that A comes in, and what we need to do over here is we need to produce a description of C like this. Okay, so now if we have this somehow, I'm going to throw an exception for now just so that it compiles. All right, so now we can do the same type Tetris as before. So what do we have? We have A, we have ADB and BDC. So what can we do with an A? Well, we can stick into the ADB. So let's start with that. So we're going to have ADB, it gets an A. Okay, so what comes out? Well, DB comes out. Okay, dB equals a to b. You don't need the types, right? Because the type is dB. Okay, so the type is description of b. Description of b, right? Or I call it d. Okay, so I'm just not going to use the types. Okay, as a dB of a. Okay, so what is the next thing? Well, the next thing is going to be what can we do with a dB? Well, we can apply it. So if we apply it, right, because it's just a function, right? Then what comes out of it? Well, it's the b. You see it on the name, right? So now we have a b. So now we already used a. We already used a to b. So now we have a b and we have a BDC. Okay, so what can we do? Well, we can go to BDC, stick the b in it. What will come out is DC. Okay, what can we do with DC? Well, nothing, because what we wanted is to produce a description of C. So we need to produce a DC like this. Okay, let me remove that, and we're pretty much done with this function composition. By the way, there's actually a mistake here, but we're gonna fix it only in the end of the video. Okay, so let me remove that. Okay, so now that we have composed Kleisli, we can also go to the Infix Notation and have some better syntax for it. So we can't just add defs over here. So because our class is going to be look a bit different, because our type parameters are going to look a bit different. So this one is going to be called Infix Notation for point free Kleisli. Okay, so there's going to be a and b. This one is going to be a db, which is going to produce a description of b. Okay, description of b. Okay, and we're going to have a function, and this time we're going to call it double semicolon, even though we're not actually going to use it, right? We will be able to use inline as well. Okay, so it's going to, compare it with this one. It's going to look very similar. Okay, so C comes in now, BDC comes in with a b that goes to the description of C, and what will this function produce? Well, it will produce an A to the description of C, like this. Okay, and what is the implementation? Well, the same as above, point free, but instead of compose, we're going to call compose Kleisli, and we're going to go give it ADB and BDC. Okay, let's see. Missing brace. Oh yeah. See, that's what happens if I run out of space. Okay, all right, so we're also going to have a few aliases, in fact only one. So this operator is present in Haskell, and it is called fish because it looks like a fish. So if you have the greater symbol, and then we have the equal symbol, and then we have the greater symbol again, then Fura code turns into a fish. So I'm going to do the same trick as over here, like this. So this is what I typed in. Fura code turned into this arrow. So this comes from Haskell, and it's called a fish. And by the way, this dot also comes from Haskell. Well, and it's called a dot. I'm gonna say dot, not to be confused with point. Okay, so now we have this fancy arrow. So now what we can do is we can go down over here. We can go to the displays. We're gonna replace them with display Kleisli, and now instead of this arrow over there, we're gonna use this other arrow, this fish operator, greater equals greater, like this. Let's see. Ta-da! The same result. Let me also do that, like this. All right, super cool. Now let's do with the prompt. What do we have it? Display. We have prompt over here, right? So now we're gonna have somewhere over here. I'm gonna call it prompt Kleisli, and he comes in. Now a description of string comes out. The description of string comes out. Okay, so now we have a description dot create 5. Okay, like this, and now we need to go up. Why did it actually work? Am I in the wrong one again? From Kleisli? Oh yeah, it worked because I didn't replace it over there. All right, so let's go up. Let's go to prompt Kleisli. If I save it like this, it's not going to compile, but all I need to do is just to, in fact, I can replace only this first one, right? No, like this, equals. Okay, there we go. Right. Okay, in fact, maybe it would have been better if I had used a different arrow over here. Maybe if I use equals. Yeah, maybe that arrow is actually better. So let me replace these ones, right, like this. Okay, so you either have a what happened? Did I ruin something? That is interesting. Maybe this is a precision thing. Yeah, it's probably a precision thing, because Scalar has precision rules based on based on the characters that you use, and maybe it thinks that it starts with a minus, and therefore it has the precision that is the precedence, not the precision, the precedence that is better for us. Okay, that doesn't really matter. Okay, so we can use this arrow. In fact, let me indent everything a bit differently so that you see the arrows, only the Kleisli arrows, so to say. So if I press Ctrl J here and I press Ctrl J here again to join the lines, then we see the regular arrows over here, and we see the display Kleisli arrow over here. Let me do that again. Ctrl J over here. Let's see over here as well. This is a long one. Okay, and over here as well, like this. Okay, so what I can do now is I can do, let's do that, and have this arrow over here. If you're familiar with for comprehensions, I already made a video about this. And if you're not, don't worry. Then this is actually starting to look like a for comprehension, right? Sort of, like very, very vaguely in a very, very abstract way. Display Kleisli. There we go. This is still on the same line, right? Spaces over here. There we go. All right. So now I can move these over there. Come on, go over there like that. These ones go over there. Like that. Okay, so basically if we had refactored this a little bit and put like this function composition like into a variable, right, and this one into a variable and this one into a variable, then you would only see the Kleisli composition, right? So only this one. And by the way, notice that we're actually not using broken effect over here, right? Because all that it's broken anyway, and all that it's doing is it composes the effect that is already there. So I can actually remove this last line and the code will still work exactly the same. Right, almost the same, but now some things are starting to to be less broken. So it's still broken because as I said in our composition over here in point 3, right, I said that there's still a bug here, but we're not going to fix it for now. We're going to fix it in a few minutes. So instead, what I'm going to do is we're going to make sure that this Kleisli composition doesn't only work for description, but it works for any special type, so to say. So any wrapped type. So what I'm going to do is I'm going to have compose Kleisli over here, and I'm gonna duplicate it over here, and I'm gonna call it 2. So the idea is that it doesn't only work for description, but that it works for any kind, any type D, right, that you can put something into. Okay, so now instead of description over here, we're just gonna say D. Okay, but now we have a problem because obviously it doesn't compile because this apply is not necessarily there, because now it's parametric polymorphism. We don't know anything about this D. It could be anything, right? So essentially none of this code will work. Right, so let me do question marks over here. Right, this part will still work. Right, so now we have a DB, and now we have the same things as before, but we just don't know how to call apply. So I'm gonna leave this code over here for now, and we're gonna do the same thing as before. So what do we have? So we already used A, we already used ADB. So now we have only DB left and BDC. So if we had some sort of helper, right, some sort of helper that will take the DB and take the BDC, right, and it would produce our DC, right, then we will be able to just return it. Oops, then we would be able to just return it like this. Okay, so what I'm going to do is I'm going to go down over here and I'm going to say private def. Let's just call it a def. I'm going to remove it in just a few minutes anyway. Okay, so if I'm going to go over here and I'm going to say helper, right? So it takes a DB, which is of type DB. So what we need over here is we need already the B and we need the D, right? And then it also takes the BDC, right, which is of type B comes in, DC comes out. In fact, it would be way better if we had more space, right? Because I'm just writing the types based on these names, okay? But maybe it would be better for you if you would actually see this, because we're writing basically the same thing, right? BDC. So now we also need to have a C. I'm going to sort them alphabetically over here, right? And if it can produce a DC, then the code will compile. Okay, so if I do this, the code compiles. You see success. Okay. So well, before continuing, I'm just gonna, it's a common convention to start with an A. So every B, hold up. So this B will become an A, and therefore this is DA. Okay, this C will become a B, and this will become a C, 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 and C. Let me check the names. Okay, so this is CA and this is ACB. Okay, this is just a rename. So now if we had some trait, right, that has this helper, I'm going to call it has helper. Okay, and it has this function. I'm going to duplicate it, put it over there, right? Has helper like this. It doesn't need to throw an exception anymore. It can just stay abstract. Okay, so the code should compile. It doesn't compile. Why doesn't compile? Maybe it doesn't like. Where are we? No, we're an object. We should be able to create a function over there. What did I do? Let's go up. Oh, is there still? Oh, there's still an equal sign. That's what we did. Okay, figure it out without the compiler. Okay, so if we have this, and the magic trick is to move this C into here, right? So now the C comes from there. And also, we're going to query this parameter list like this, and now this starts to look like flat map. This is exactly flat map, and this is exactly monad. Well, technically this is a part of the monad, but we're going to get to this in the upcoming videos. Okay, so this is now a monad, and flat map is called differently, depends on the language that you're from. In Haskell, for example, it's called bind. So let's inline that, and it's just going to call flat map with CA and ACB, and also in Haskell another operator is used, which is greater equals, and Fury code is going to convert into this again. So I'm going to say greater equals, which is, by the way, almost the Haskell logo. Like if this was a lambda, then this would be a Haskell logo without the space actually. Okay, so we have flat map, which is also called bind. Okay, sometimes. All right. So what happened there? What happened there? Oh yeah, I forgot that I carried the function. Hold up, like that. And like that. Okay, it's only carried for better type inference. We're going to use monads as type classes, and because we're going to use monads as type classes, it is common to have a so-called summoner for them. So we're going to have an object monad, and we're going to have apply, where a C comes in, which is a monad, right, or which has a monad, so to say, and it will just return this monad, okay, by calling it implicitly, which is a function that's defined in predef, and saying give me the monad for C. Okay, so what we can do now is, instead of using the helper, we can actually remove the helper. We can say that the Kleisli composition, that it requires a monad. This is what I have been explaining in the previous video. Okay, and now that we have the monad, we can retrieve the monad, right? We can say, let's actually do it over here, right? We can just say, give me the monad for D, and I'm just going to call flat map on it. Flat map like this. Okay, so this code should now compile. Now it actually compiles, and the code is running because it is running the regular compose Kleisli function. Okay, but if we remove the regular compose Kleisli function like this and put it over here, right? It should still work, maybe, probably. Let's see. Let's create more space. Like this, like that. All right, what does it say? Couldn't find implicit value for evidence parameter, blah, 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 blah. Okay, so we need to go to our package object where we have this. Man, it really sucks with so little space. Okay, like this. Okay, so Infix Notation to Kleisli. So now over here, we need to say that this doesn't work only for descriptions, that it actually works for any D which has a monad. So we can just go here, and over here we can say, please give us the monad for D, like this, right? Okay, 9 errors found. Okay, it's getting worse. Okay, not found type D. That's easy because we just need the type over here. It's not C, it's D, like this. All right, 4 errors found. Okay, so before we had 2 errors, and now we have 4 errors. In fact, I didn't want to do this part. I made a mistake. I didn't want to do this part first. So now we have 2 errors that are coming from here because it says, hey, I don't have a monad for the description. One is from here, one is from there, and the other 2 are coming from where is it? In point 3, it's coming from here. Okay, so so what we need to do is we need to actually go in to create the monad for the description. So we're going to go to description over here, and we're going to just create, and by the way, we don't need the broken create anymore. Okay, so what we're going to have here is we're going to have an implicit val m, which is a monad for description, right? So it's a new monad for description equals, and now we're going to say final override, and what we need to override is the flat map. Okay, so we're going to go to point free. We're going to take the flat map like this, over here. And did I throw out? No, I didn't. So we can take this like this. We can paste that in. This is what we had before. Let's see if it actually works. Okay, so we have, okay, so DB is actually called CA, so it produces an A. Okay, and BDC is actually called ACB, so it produces a CB, and what we need to return is CB. And in fact, yeah, that's exactly what we need. Let's do it like that. Expected start of definition. What did I forget? Oh, there's an equal sign over here. It shouldn't be. All right, we got more errors than before. Let's see what we did wrong. Could not find type monad. All right, okay, so what we need to do is we need to go over here, and we need to cut this out, and we need to put it in its actually the companion object as well. We need to cut it out like this and put it in its own file. Okay, so we're going to create a new file. I'm going to call it monad. I'm going to put it in, and we're going to put it in the package fp library. Okay, let's see if it's happy now. Okay, 4 errors found. Couldn't find type C. What? Oh, it's called D. Oh man. Okay, so in the description over here, type C. Okay, every C is obviously a description. Okay, description. Okay, so the C is a description. C is a description over here. All right, not found value B. That's because it's an A. ACB wants an A. Okay. There we go. I couldn't find the implicit value of parameter m, which is a monad of description. I believe the problem here is that we're using a type alias. So our description is a type alias, and usually you put a monad into the companion object of your of the description, which will be a case class in just a few seconds. So what we need to do is we need to go to point free and probably just not to point free, to the point free program. So I'm going to switch like this, and we probably just need to import description, so that it can find the thing. I'm just gonna import it over here. Import description like this. All right, yeah, so now it works. Now it has been found. So what we have now is, instead of having this one big description, we're composing a lot of small ones, and we're composing them automatically while using the monad. And it should have exactly the same effect, and it will have exactly the same effect if we actually fix our monad. So if we go over here, no, hold on, this is the point freestyle. Let me actually do that. Okay, where's our description? Okay, if we go to our monad, which is over here. So the problem here is this this whole by name parameters and this whole lazy evaluation. So over here we need to produce a description, but if we just produce a description at the end of the method, then the things that is happening before is being the effects that are happening before, they're happening before the description is constructed. And because Scala is a language with strict evaluation, we basically need to make sure that the first thing that we do is we create this description. So over here we're just going to say description.create, right? And now because this is a CB, and we need just to produce a B, right? We're producing a description of B. So if we say in description create before this entire block, then over here we need to produce the B. So how do we produce the B? Well, we just call apply on CB. and now we can return B, and now everything should turn green. Okay, so now everything is back to green, and we have our first version of a monad, and we have our first monad, which is called the IO monad, which stands for input output, and can describe any effect that can come into the program or that can come out of the program. So the last thing that we're going to do is we're just going to remove this type alias and remove it and replace it with a proper data structure that will allow us to get rid of this import, and it will also allow us to put this type alias into its proper place, which is this description file. Okay, so we're going to go to the package. We basically can cut this out, and I'm going to save it. I'm going to go to the description. The code is not going to compile for a while. Okay, so we can go over here. We can paste them in. Okay, so both of them can be private now. Okay, so now we're going to have a final case class. We're going to call it IO, and we're going to have a function called unsafe run. And what it will be, it will be a description of A, right? So basically it's a description of A. But now this is going to be the only place where we're going to use it. So we can just say this. Okay, so IO just wraps this function of obviously A, and by the way, it's going to be a covariant function, covariant class. Okay, and we can also extend any val over here, right? So now we don't need the description. Now everywhere where we use the word description, we're just going to use IO instead. Okay, so this is now our IO monad. Let's see. Value apply. Okay, so now instead of apply, we're going to say unsafe run. Okay. What else is there? Description line 7. Okay, over here we need to produce an IO like this. All right, so now let's go to, I'm just going to go through all the files just to make sure. Okay, point free, that is fine. There's a monad, that is fine. In the package over here, we shouldn't be using the word description anywhere over here, right? There's no description. Yeah, there's nothing over here. So it actually doesn't compile in the application library. So we're done with the functional library. So over here, we're going to go, we actually don't need to import the description anymore, right? Everywhere where we say description, we're just going to say IO. Okay. Point program, same problem. Description, we're going to have IO. Okay, what else? Interpreter, line 10, which is, no, not like this, IO, and IO, and interpretation means to run unsafe run. Yeah, there we go. All right, so let's just walk quickly through everything that we have here. And by the way, by the end of the series, I'm going to rip out the functional library out of this multi-build project, and I'm going to publish it on GitHub so that it's so that it's a standalone thing, and you can look at the code. Okay, so what we have is we have the description, right? By the way, we should rename the description to IO. Okay. So we have IO, which is just a case class, and it has an object IO, companion object. It has the method called create, and it has a monad, right? So the monad has just a flat map. And what else do we have? This is our monad. This is how it looks like. It just has a flat map, and it has a helper that can summon the monad out of the implicit scope. What else do we have? We have point free, which has the regular composition and the Kleisli composition, right? Which look very, very similar, actually. Right, so that's what I meant in the previous video, right? So monads are there just to make the automatic composition of special kinds of functions of Kleisli arrows possible, right? So this thing would not work without monads. Okay, they've just been called monads. Okay, but the implementation, look, it's very, very similar. Okay, sort of, but this part is programmable, right? Whereas the regular composition is always the same. Kleisli composition can do different things based on the monad. Okay. And by the way, if you ever heard that monads don't compose, they don't compose because over here, this D always stays the same, right? So for example, if you start composing the IO monad, in the end, you have to end up with an IO monad, okay? What else do we have? We have the package object with just the fancy syntax. I'm going to remove this one, actually, okay? In fact, I'm going to remove all of them. I'm just going to have the arrow here, and I'm just going to have the Kleisli arrow, okay? So, yeah, we just have the comments here. We don't actually need this type alias, so I'm just going to remove it. Okay, so this is what we have, right? So our functional library is super tiny for now. It just has this infix notation. It has two kinds of composition. It has the monad and it has the IO monad. And the application looks very, very slick. Okay, this is the old one. Okay, And this one, it is written in this weird point-free style, but in the next video we're actually going to do the same thing for the regular program, and you will see there why monads are important as well, so that our point-free style becomes less pointless. All right, that's all I got for you today. It's been Vlad, devinside.com. Like this video if you did, subscribe if you want to improve the developer inside you. If you find my videos valuable, consider supporting me on Patreon, and most importantly, take care.